Alright guys, we're going to spend a decent amount of time going over partitions on the Linux file system. So each distribution's installation guide contains, or at least it should contain, a section on partitioning your hard drive. Personally, I favor the KISS principle, or KISS principle, which just stands for keep it simple, stupid. Okay, so this is especially for beginners. Alright, so we just want to try and keep our partitions as simple as possible. Don't need to get fancy with it. We saw on our server, or our VirtualBox, we even just let it do it automatically. Okay, so that's going to be the easiest way to do it. So if you are installing a server that will serve multiple users simultaneously and provide a myriad of services, you will want to read the manual sections as well as the partition mini how-to. This is an excellent document detailing the reasons one might want to create the 7 or more partitions. Okay, so that's a good document to read to actually see how to install each partition on your hard drive. In our case, on VirtualBox, I went ahead and did it for us. So how different partitions and storage is managed on Linux servers is through LVM, which stands for Logical Volume Manager. Okay, this is a tool for logical volume management, which includes allocating disks, striping, mirroring, and resizing logical volumes. So striping and mirroring is a way that data can be stored. So with mirroring, you're just going to store the same data on another disk. And striping means you're going to take one strip on a hard disk and you're going to store that same strip on another hard disk. What this is doing is creating redundancy and backup. In case one disk gets corrupted, you still have the info on the other disk. So with LVM, a hard drive or a set of hard drives is allocated to one or more physical volumes. LVM physical volumes can be placed on other block devices which might span 2 or more disks. The physical volumes are combined into volume groups, which can then be turned into logical volumes. I'm going to go ahead and highlight these as well too, guys, because this is really the main parts. Oops. This is really the main parts of LVM. Oops. Don't want all of that. Okay. So we've got our physical volumes, volume groups, and our logical volumes. So the physical volumes are combined into volume groups, which can then be turned into logical volumes. With the exception of the /boot partition, the /boot partition cannot be turned into a logical volume group because the bootloader cannot read it, okay? So that's the only partition that cannot be turned into a volume group or logical volume. If the root partition, which is // is on a logical volume, you can create a separate boot partition which is not part of a volume group, okay? Since a physical volume cannot span over multiple drives, to span over more than one drive, create one or more physical volumes per drive. So let's take a little look here visually at what this kind of looks like. So we can have a lot of disks with all having different physical volumes on it. What we can do is we can throw all these different physical volumes into a volume group, and from here we can start shaving off logical volumes from it, okay? So this is nice because we can have a ton of different disks. We can throw whatever storage they all have on them separately into one place, which looks like one disk, and from there we can create logical volumes that can be used for file systems. Okay? So let's take a look at the file system overview. So, have you ever gone looking for a book in a library? In order to find what you're looking for, you must understand the library's file system or method of organization. Okay, so this is a good analogy for how the file system works on Linux, kind of compared to a library. So, fiction books are easy. They use a simple type of file system commonly known as the alphabetical order, right? We sort it by alphabetical order. Non-fiction books can be tougher because they are a different type of file system, the Dewey Decimal System. Now the problem is what if you don't understand the Dewey Decimal System? What if you only know the title of a book and you don't know whether it's fiction or nonfiction? How would you be able to find that book? Luckily there's a librarian to help us, and she has created a card catalog, or in most libraries now a computerized catalog, listing all the books available and where to find them, okay? So now let's look at our hard drives as books in a library. So like the library, your hard drive can have different file systems, okay? The operating system is going to be your librarian, who's provided the directory tree, also referred to as the file system with a slightly different meaning, as a catalog of the files available, okay? So another partition you're going to need on your system is something called swap. Okay. This is space on your hard drive that can be used as virtual memory. So it's very similar to RAM, which stands for random access memory. Virtual memory allows your computer to run large programs or perform complex tasks even if it does not have enough physical RAM to do the job. So when RAM runs out, your system goes to this swap. Okay? It's a lot slower, but it works just the same as RAM. The amount of swap space required is a matter of religious argument among geeks and hackers, and entire volumes can be written about the subject. To keep it simple, remember that KISS principle, keep it simple, stupid. Create one swap partition that has 50% to 100% size of the physical RAM in your system. So you have 2 gigs of RAM, then make 1 gig of swap. 4 gigs of RAM, make 2 gigs of swap, or make it a 1-to-1 ratio. So if you're short on RAM with plenty of drive space, go large. So if you don't have a lot of RAM, but you have tons of storage, you might want to just create a lot of swap space so your system can run a little bit faster. Now keep in mind, this is not as fast as RAM. It's not going to make up for having a lack of RAM, but it will help. Now if you have only a short amount of drive space, but you have lots of RAM, then go ahead and go small on it. You know, do just 50%, maybe less. So next thing we want to look at here is other partitions to consider. First one being root or /. The root file system is represented by a /. It is the top of the directory tree and contains Linux and everything that you will install with Linux. So file systems for, so see the Linux virtual file system for details. So this is roughly equivalent to your C drive on Windows. You know, it's going to be the main drive. And you must create a partition for this directory. Another one is going to be /home. Make sure you're writing these down, guys, because these are important ones to know. So you have /root, /home, which we're going to talk about now. We had /swap. So /home is the third and final partition you should create, which will hold your home directory. Okay. In our last course, we saw that was /home, /kdowns. For you, it would have been different depending on your username. So this is the place where all user-specific files, your data in other words, is stored. It is roughly equivalent to the My Documents folder on Microsoft Windows. On a multi-user system, each user will have his or her own directory. So there can be a lot of different home directories on one machine just depending on how many users you actually have on the system.